Hello everyone, I am Riddick Kakati, a PhD scholar at the Indian Institute of Technology, Guwahati, and presently also an exchange student at the George August Universität Göttingen, Germany. It's a great honor for me to present my research here. So basically, I am working on a near real-time water quality monitoring web GIS application using Google Earth Engine. The massive datasets and the resources provided by Google Earth Engine, in addition to a powerful and user-friendly IDE, allowed me to carry out my analysis fast and easy. With my experience of working in Google Earth Engine, I would like to mention here that during the COVID crisis, this tool allowed me to carry out my complex geospatial analysis using minimal computational resources in my laptop. So with this thought, I would like to begin my presentation here by mentioning that Google Earth Engine has brought a new era of geospatial computing. So I would like to share my presentation. So I'll be presenting on near real-time water quality monitoring using Google Earth Engine apps. I've been mentored by Professor Subhashish Datta from the Indian Institute of Technology, Department of Civil Engineering, and also by Professor Santosha K. Dwivedi from the Department of Mechanical Engineering of IIT Guwahati. So this is all about me. So basically, I'm based from Guwahati, and I have done all my former education in Guwahati itself. And this is where I belong, near to the banks of River Brahmaputra. The Indian Institute of Technology has a very beautiful campus, and it's situated right in Guwahati, which is the capital of Assam state of India. And these are my experiences in terms of publications and book chapters and my conferences. So coming to the motivation of my study, as we know that the urbanization is occurring at a rapid pace, and this has led to increase in impervious surfaces, which has led to climate change, and also a change in aquatic habitat as a consequence. And this has led to loss of ecological balance. Now, the solution to this problem can be in terms of ecological monitoring systems. Now, the countries like France, Germany, and UK have already established such systems, but these systems are field-based and are time-consuming and not at all economical. So coming to the satellite-based near real-time hydroecological monitoring system. So if we can generate something like that, then it will help us a lot in generating maps on the go using resources such as Google Earth Engine. Now, for achieving that, I've tried to develop an app which has the following features, such as it has less modules, which leads to faster computations. And also I've tried to optimize the server functions and the client operations so that the app is fast. And if we give too many server commands at one go, then there are chances that the server may reject some of the commands due to more computational power being demanded at one time. So basically, to avoid that, also to make the app a bit faster, we have used more server functions and less client operations. In a way, we have optimized that. And also this UI, which I have developed, it has many features, such as we can enter the date on our own as a user input, and also some of the coefficients to modify the equations that are embedded so that it can give more realistic values or more field matching values. And also, as we all know that Google Earth Engine allows for server-based computing, so it requires less of computational resources on the client side. So also some additional features such as the app which we have developed generates maps on any user-defined water body. So basically we click on any locations within the inland water body shapefile, which is basically a Google Earth Engine dataset added in the background to enable the user to select the water body in which the maps generation is desired. So also to guide the user, we have added some exception handling capabilities, and also the image styles that are processed by this app can be downloaded directly in a very low resolution as per the Google Earth Engine allowance at this time. But that can be used for preliminary analysis before carrying out any complex analysis. Also, the app consists of multi-parameter analysis of ecological parameters such as NDCI, which is normalized difference chlorophyll index, NDVI, which is normalized difference vegetation index, GNDVI, which is greenness normalized difference vegetation index, then NDTI, which is normalized difference turbidity index. In addition to water temperature, water depth, and Sentinel-1 amplitude images, which are also available as a Google Earth Engine dataset. Also, we can get the point value of the concentrations or the values of different quantities mentioned above as an interactive way. By clicking on the point locations, we can get the concentrations on the go. So these are some of the features that have been incorporated by Google Earth Engine apps. And also, we have added a user-defined legend display, such as we are having a lot of parameters, displaying all the legends at one go will make the app clumsy. So we have enabled the user to close all the legends or to make the legends reappear as they want or at the time at which they want them to. So in addition to that, we have also added some additional user instructions to make the user more aware of the things that can be done with the app. So that's all from my set of my research, which I'm currently doing on water quality analysis using satellite-based remote sensing. I would really like to acknowledge the team of Google Earth Engine for developing such an interactive and user-friendly app, which has taken the geospatial analysis to the next level. And also, this kind of app has also enabled users with lesser computational resources to carry out their analysis using the server-based functions and the server-based computational facilities provided by Google. So with this motive and my aspirations that the Google Earth Engine will further develop and enable more user functionalities, I would like to end my presentation here. So thank you very much. Have a nice day. Thank you. So here we are coming to the demonstration of the app. So now we are entering the dates of our analysis. So once we enter our dates of analysis and click on the satellite tile, that is Sentinel-2 in our case. So just for demonstration, we can also use Landsat. Now we are going to click on our area of interest, which is just a mouse click on the point of interest, and it will then extract the satellite tiles available for that period in that area. Basically the Sentinel-1 and the Sentinel-2 tiles available in that area, and it will load up that layer. So it takes some time because a lot of processes in the background are going. So the tiles are being loaded now. So this is the Sentinel-1 tile. Basically the SAR VV and SAR VH polarization tiles are being loaded. So here now we are going to see that once we click on show legend button, then the legend shows up, and we can also close the legend buttons so that the legends disappear from our screen. So now we click on generating the main tiles, which will bring up the NDVI, the NDCI, and water depth, water temperatures, and some other data which can be used for ecological monitoring. So this app is taking some time again because this is the second level of analysis going on, where the raw tiles are being processed to surface reflectance tiles, and these surface reflectance tiles are then again processed for generating the final maps. Now we are using the raw tiles in our case because most of the time in our region the surface reflectance tiles, for example in 2016, most of the time the surface reflectance tiles were not available. So to carry out our analysis for a longer period of time and to enable near real-time capabilities, we have to use the raw satellite tiles in our case. So these raw satellite tiles are being processed into surface reflectance tiles, and then these surface reflectance tiles will be processed into the various data or the results that we require. So the total app time is around less than 4 minutes that requires from the data input to the final map generation. Now we can see that the results have been generated, and this app is running in real time. So this is the time that is actually required by the app to generate the results. Now we are just deactivating the SAR tiles and now selecting our chlorophyll map, for example. Now the map has been loaded, and we can see that we can click on the mouse pointer location and we'll get the point concentrations or the value of the quantities at that point. We can also show the legends again by clicking on the show legend button and then click on close to close the legends. So we can click on any other point to generate the value of the points in that location. We can also generate some charts based on the point locations which we have defined in our code. And now we can see the points and the map has been loaded in the background, and we can zoom in and also see the distribution of the quantities.